In PHP, when we call a function and we pass an argument to it, or a number of arguments, in general, the value of any variables that we pass as arguments to that function remains unchanged. This is because the functions usually use call by value. Some of PHP's inbuilt functions, however, also use call by reference, and we can also use call by reference when creating our own custom functions. Let's take a look at an example and make clear what this distinction is. Let's first of all write a very simple function, and this function is so simple that there is no way we'd ever use it in a real PHP script that we're going to use for something other than showing an example such as this. And we're going to call this function multiply by 10, and it's going to take one argument, and that is the num variable. And what we're going to do is we're going to multiply the num by 10 and set the value of num to that using the combined multiply operator. And then we're going to return the new value of num. And that's our function. Now, if outside our script we were to define a variable of some kind, let's call it years, and we're going to set the value of years to 3, and we're going to call the multiply by 10 variable using the multiply by 10 function using the years variable as one of the arguments, its only argument in fact. Now, before and after this function call has been made, the value of variable years remains at 3. Let's prove that by copying this line 3 times. Actually, we're also going to put in a line break just to make this more readable. And we're going to copy that line 3 times so that this function is called 3 times. Let's take a look over at our web browser, and as we can see, 30, 30, and 30. So 30 times 3 is 10, so every time this function is called, years has remained at the value of 3. Now the reason for this is that in this function call, this variable here, years, has been passed to the function by value. So the value 3 is passed to this function, multiplied by 10, and returned, rather than the variable itself. So no change has been made to the value of the variable. However, it's very possible to make a very simple change in the syntax of our function and make it act in a very different way. If we simply put an ampersand, like that, or and sign as it's more commonly known, before the name of any argument in our function definition, then let's take a look at the browser and we'll see what result that small change has had on the way our function works. As we can see, the value of the variable has been changed each time. Each time it's been multiplied by 10. So as we can see, by using call by reference, we can give our functions, we can allow our functions rather, to act directly upon the variables that we pass to them as arguments. So far, we've only looked at functions that can take a specific number of arguments. However, sometimes we'll find that when we write our function, we won't know how many arguments the function is going to be passed when it's called later on in the script. Perhaps the function is going to be called several times, and the first time it's going to be called with 3 arguments, second time with 10 arguments, and the third time with no arguments at all. We'd need a flexible function that can handle a variable number of arguments. Let's take as an example a simple function that is going to list some ingredients. And let's say we assume that our food product, whatever it is going to have only 3 ingredients. We can simply list them like this, and so long as there are only 3 ingredients in our recipe, then we shouldn't have a problem. Let's say we call the ingredients function with 3 arguments. Flour, eggs, and sugar. Now, if we go over to our browser and refresh, we'll see that it handled it fine with 3 ingredients. However, if we add an extra ingredient, then we're going to have problems in that the function won't be able to pick it up. And if we take away 2 of those ingredients to leave 2 arguments when we call our function, as we can see, even worse, we get this very ugly error popping up, missing argument 3 for ingredients. Now that is a bit of a problem, as we can see. So any calls made to this function without the full 3 arguments that we've specified here are going to throw up an error. Any calls made to the function with more than those 3 arguments, the 4th, 5th, 6th, 7th, and so on arguments are all going to be ignored. So we need a way of making this a lot more flexible. Help is at hand as of version 4 of PHP with the inclusion of a certain number of functions to handle variable arguments when functions are called. And these functions are called func numargs, func get arg, and func get args. And here's where it gets a little confusing. These functions can only be called from within another function. Otherwise, they themselves will throw up some kind of error. Now, what each of these functions does, the first one returns the number of functions in this function, in the function from which it was called. This function will return a specific argument, the value of a specific argument, and you have to specify that as the argument to the func_get_arg function. And this argument, I beg your pardon, this function will return an array containing all the functions in the parent function. Right, let's see how we implement those. and hopefully this will begin to make sense. We'll just use a simple for loop to loop through the arguments, and we can use, this is where we use typically the func num args function, and then we can use the func get arg function along with the number of the loop as the number of the function, number of the argument that we wish to call. We better put in a line break after that as well. Let's save that and take a look in our browser. As we can see, ingredient O is flour, ingredient number 1 is eggs. We're still getting this error message simply because I forgot to take out these here. Now, when we define a function with a variable number of arguments, we can just leave these brackets, which normally contain the arguments of the function, completely empty. We just open them and close them again. That way, when we come to run our function, it will only be accessing the functions such as func num args in order to get at the arguments, rather than trying to access the arguments directly through here. So let's try this out with and I have no idea what this would taste like in these proportions. Well, let's take a look to see if our function is working. As we can see, it can handle as many ingredients as we throw at it. You may not need to use functions that contain a variable number of arguments until you have started using quite complex structures in your scripts. But it's good to be familiar with the territory and to know the kind of things that you can and can't do within PHP even before you start using them yourself. So I recommend you have a play around and try to create your own functions with variable number of arguments. A very neat trick that we can use in PHP is to call a function without knowing exactly what function we're calling. And the way we do this is to use a string variable in the place of the name of the function. For instance, let's set up a very simple function that takes no arguments and simply echoes some sort of result to the browser. Let's say just a line to let us know that that function has been carried out. And then we can simply call the function in the way that we normally do, like this. However, if we set a variable and as the name of that variable we write the name of the function, I beg your pardon, as the value we put the name of the function in, then we can call that function simply by using the string variable's name in place of the function name. And then when this line is executed, PHP will look at this string variable name, find the value, and replace the string variable name with the value. Let's take a look at what that does in the browser. Function is called twice. Now, as we can see, these are the two times at which the function has been called, and they act identically. This is a very neat trick which can be used when, for instance, depending on user input, various different functions could be called, and we don't know which way the user is going to go when we write the script. We can simply assign a variable according to the user input, such as this, and then when it comes to carrying out the function, instead of this line, which is essentially static, we can use this line, which is more dynamic and allows for variable functions to be called through the same statement. In this movie, we're going to take a brief look at recursive functions. A recursive function is simply a function that calls itself. Now, an innate problem with recursive functions is that it is very possible and easy to set up a situation in which the function will continue calling copies of itself forever. This works in a very similar way to a while loop or a for loop. You have to put in a condition at which point the function will stop calling itself. Otherwise you end up with an infinite loop, and the computer gets stuck within that loop until it runs out of memory and gives you an error message. Let's take a look at an example so we can see the way one of these things work. Most functions do not call for recursion. Only very specific kinds of functions generally call for recursion. One example of that would be a function that I made quite recently to answer a specific need I had, which was to show all the elements within a multi-dimensional array. It's very easy to loop through a single-dimensional array. You simply either use a for loop or you use list and echo as we found in an earlier chapter. However, with a multi-dimensional array, we have no way of telling if we're going to feed this multi-dimensional array into a function and expect the function to return all the elements and, for instance, simply echo them. It would be very difficult without recursion for the function to determine how many arrays there were within the array, since a multi-dimensional array is essentially an array of arrays, or even possibly an array of arrays ad infinitum. The function needs to be very flexible, and it also needs to ensure that it escapes and terminates from the loop and stops once it's found all the elements. So, let's have a look at the way our function could work. We're going to call our function show all elements, and it's going to take one argument, and that will be the array that it's going to be dealing with. Then we're going to need a for loop to loop through all the elements of the array. I should add that this kind of function rather, will only work for numerically indexed arrays. I would have to rewrite this function in a slightly more complicated way to allow for associative arrays, but for the moment, let's keep it relatively simple. So this for loop loops through each of the elements in the array, and we're going to assign the element variable to the element of the array that we're dealing with, just to make it easier to refer to. Now that the for loop has been executed once and it's looked at the first element in the array, the first thing it has to do is to determine whether this element is a simple variable, in which case it should echo the variable, or whether it's an array itself, in which case we're going to have to deal with it as an array. We're going to use a function called getType. What getType does is it returns the type of whatever variable we put as its argument. So that's a good way of testing whether something is, for instance, an array. So if the element is another array in itself, then we're going to have to deal with that. We'll deal with that later. Let's leave that line blank for the moment and have a look at what we'll do if it's not an array. We're simply going to echo the element, the contents of that element, with a line break. And then we're going to close up all these trailing curly brackets here. Now this line is the crux of the point in the function where we're going to need to use recursion. If the array is an element, then we're going to have to show all the elements within the array. So the best way to do that is to use the function itself to work through the array that we've just found as an element of the parent array. And then, in turn, when the showAllElements function is run using the element as the argument, then any arrays that are found within there will be passed to a new copy of this function, and so on and so forth, until every element has been found, at which point all the functions will have finished operating. This is not a return function. This simply echoes all the elements it finds to the browser. There's no return made with this function. Let's set up a multi-dimensional array, and we're going to try and make this one, although all the elements are going to be string variables apart from the other arrays within the array, we're going to try and make this one a very irregular shape to deal with. First of all, we've got, as the first element in our array, we've got a single string variable, and then we've got another array with 3 elements, and then we've got, let's say, another string literal rather. Then we've got another array with a string as its first element, and then another array following that. And let's use an array with only one element as final point of confusion in this rather confusing multi-dimensional array. Then we're simply going to run the function that we've set up on this particular multi-dimensional array. Let's save that and take a look in our browser, and we refresh. As we can see, blue, green, turquoise, maroon, grey, purple, white. These are all the elements within our array that are not arrays themselves. So, as we can see, recursion can be very useful, specifically when we don't know exactly how many times we're going to have to run a certain function. But once again, I should state that caution should be used, particularly because it's very easy to skip out this kind of condition, the termination condition, which is going to make sure that the function will not call itself an endless number of times and therefore generate an error. In this movie, we're going to look at a couple of functions which will allow us to show the date and time in pretty much whatever format we like using PHP. First of all, we need to use the time function. Now this, if you're not used to it, can act in quite a counterintuitive way. What the time function displays when we simply call the function on its own is the Unix timestamp. And this measures the number of seconds since the beginning of 1970, New Year's Eve. So if we ask PHP for the time like this, we're not really getting the time. What we're really getting is a code that represents in a very absolute way how much time has passed since January the 1st, 1970. Fortunately, PHP includes a very easy way to access the time in a much more human-readable way. What we use is a getDate function, and as the argument to that, we pass the timestamp, the time function. Let's set the value of that to a variable. Now we can't use that immediately on its own. Let's try and do that and we'll see why. If we save this script and check that in our browser, as we can see, current date has been set to an array. So PHP is not showing us all the contents of it because we have to go through the array and pick out the ones that we want. Let's take a quick look through this current date array that we've produced and see what different kinds of data are stored within the current date array. We're going to use the same kind of loop as we use generally with associative arrays to using list and each to move through all of them. So we're going to show both the keys and the values of each element within this array. Let's take a look at that and we'll see the way that PHP formats the current date variable that we've just created. If we refresh our browser, we'll see that the array consists of a lot of different kinds of information about the current date. First of all, there's the date stamp, which appears right at the bottom of the array, which is what we got simply from calling the time function on its own. Then we've got the seconds, minutes and hours of the day. So we can presume 18:11, we can presume that it's 10 past 6, near enough. M day may not be quite so obvious, that's the day of the month. W day, that'll be what day of the week it is. And mon will be the number of the month as a numeric value. We've also got month down here to give the name of the month in a word. And we've also got the day of the week as a word as well. So as we can see, there's also Y day, which represents the number of days it's been since the beginning of the year. We've also, of course, got the year that we're on at the moment. So as we can see, the date functions in PHP are very flexible and allow us to use this data to produce dates in pretty much whatever format we want. Let's have a look at a quick example. If we take out this list here, and we're going to write a quick example to show how we can use PHP's time and date functions to produce dates in whatever format we like. We're going to use the weekday element of the associative array that we've created, this weekday element here, and then we're going to use the mday, and that'll be the day of the month. Then we'll use the name of the month as a word. Then we'll put another space in. And then we're going to put the year. We can do very similar things to output the time. We also access that from our current date variable that we've created. If we take a look at this in our browser, as we can see, the facilities in PHP allow us to use words, numbers, in whatever configuration we like, to produce the date and time in pretty much any format we want. It would be no trouble to produce dates, for instance, in the American format, which puts the month before the day of the month. Just as easy to do that as it would in another format. So, we've looked at ways to avoid repetition of writing code within the one script. However, it's quite possible that having written a function, we'll find that we want to use that function within more than one script. And although it may seem like it would be possible to simply copy and paste the function definitions from one script to another, that will cause problems when, as inevitably will happen, you'll either find a bug in one of your functions and you'll have to fix it, in which case you'll have to go through every script in which you've included the function and make that change, or you'll find a new, more efficient way of writing that function. And the same will apply. You'll have to go through and make the change to every script in which you've defined that particular function. A way to get around this problem is to store in a separate PHP script a set of common function definitions which you can then load in to every script in which you're going to need them. Let's look at an example of the way this could work. If we have a look at our sendFeedback.php script that we made in a previous chapter, then we could, for instance, make a function out of this line. Let's do that. And we're going to include that at the end of the script. And we're going to call the function isValid. We better call it isValidEmail to be absolutely precise about that. And then we're going to just simply say return this value. So it'll return either false or true, depending on whether this pattern is found, and therefore on whether the email address given fits the pattern for a valid email. Then we can go back up in our script and we can simply call this function by using the bang symbol and then is valid email with the email variable. We save that, and our script should now work in exactly the way it has always done. But we've improved it in that we have this function which is now separate from the rest of the code. However, if we wanted to check for a valid email in another script, then we'd be better off including this function as an external file, an external resource. Let's first of all save this to the clipboard by the cut command, and we're going to open up a new file, and our include file is going to look exactly like any other PHP script. I'm going to use the same tag, and then we're going to save that, and we're going to call it validation. And it's a good idea for your include scripts to give them a useful name at the end, such as inc for include. Let's save that, validation inc, and we're going to go back to here. Now our function definition has been taken out of the file, and the way we include that file is simply to use the include function. Validation.inc, and we should save our validation.inc file along with, in the same folder as the sendFeedback.php file and any other files that will be using the validation.inc functions. Let's save that. One thing to remember as well is that although in this example we only have one function, it may well be that we have a set of standard functions, any number of functions within this one file, that we can then load in and use in any of our scripts. So this is a very flexible way of working. If we take a look at our feedback form and we try and enter an invalid piece of data into the email field, and as we can see, it's picked up that we've entered an invalid address. If we go back and change that to something more reasonable and submit those details, as we can see, it's accepted it. So we can see that even though the isValidEmail function is not present in the sendFeedback.php script, it's treated in exactly the same way as if it is by using the include function. Now there are two rather similar functions which carry out very similar tasks, one of which is the include function we've just used, and the other is the require function. Now the include function will only be carried out if the part of the script in which that statement is contained actually gets carried out. So say if we kept it within an if condition, then we could possibly make our script run slightly faster by only using this code if we were going to need it. For instance, if we use the include function here, and instead of putting it on this line, we put it down here on this line, then we'd only load the validation file once the PHP script had got past this set of conditions, and so only if it was needed would it be included. The require function, on the other hand, will always load the included file no matter whether or not that part of the script is ever going to be evaluated. The plus side for the require function is that, and I'm not sure of the reason why, it works slightly faster. So, once again, a matter of what works in the particular script and your personal preference. However, it should be noted that errors can spring up if you load the same include file twice. So it's a bad idea to put a command like this into a loop or into any part of your script which is going to be executed more than once. In these two movies, we're going to look at our options for dealing with errors in PHP. During the course of testing any of our projects, we're inevitably going to come across quite a few of PHP's error messages. And very possibly, despite our best efforts, our end users are at one point or another going to end up seeing one of these error messages as well. Now, the kind of error message that we really don't want our users to have to see is the standard error message that's put out by PHP when it runs across an error. Let's take a look at one of our scripts. This one we made in a previous chapter. This one is for dealing with the feedback that a user gives when visiting a hypothetical website. All we're going to do is introduce arbitrary syntactic error into the code. Now, we have the db variable here, and if we introduce an extra letter, then the dbn variable has never been set, is therefore empty or null, and MySQL selectDB function attempts to carry out the selection of a database on a non-existent connection. This will inevitably generate an error. Let's save our script, and we're going to go back to the HTML page which contains the form with the data that we're going to send. As you can see, I've put some random dummy data in to test this script, and we're going to try and submit this form and see what happens when PHP runs across our deliberate error. Now, two things are wrong here. First thing that's wrong is that we really don't want to see this, because if it can't do what it intends to do, then we don't want to be seeing any comment to the effect that the comments have been effectively added to the database. They haven't. Our PHP script is broken down, as we can see from this error message. The other thing that's wrong with this page is that this is really an ugly error message. This is very useful to us as programmers because it tells us what script the error's on, exactly what line the error happened, and what kind of error it was. This error was a warning. There are different grades of errors, which we'll get into later on in the next movie, and this tells us what kind of problem it came across when it generated the error. So what can we do, first of all, to avoid getting this thank you message that we shouldn't be seeing, and also to replace this error here with something more user-friendly? Let's take a look at our script. And what we're going to do is we're going to use the die command. And what the die command does is it works very similar to the exit command we looked at in an earlier chapter, and that is it terminates execution of the script. As soon as a die command is carried out, the script will stop. The difference is that die allows you to generate some kind of message to explain to the user why everything stopped at that point. We use the die command in this case in conjunction with the OR statement, and that is set up with this syntax. And we're simply going to say, as our error message couldn't select database, Let's save that, go back to our browser, go back to the previous page, and submit the data again. As we can see, our custom error message has come up beneath the ugly error message. Now, this page is slightly better. For one thing, we've got our custom error message coming up, and we haven't got the spurious "thanks, we've entered your comments on the database," which came below erroneously. So clearly, the user knows that the comments haven't been added. However, we're still getting this very ugly error message, as well as our custom error message that we specified. So what can we do about this? First of all, if we go back to our script, at the beginning of this line, we can add an ampersand followed by a space. All this does is suppresses the generation of any standard errors that might be put out by this line being executed. If we save that, go back to our browser, and submit the form data again, as we can see, this line on its own has been output. No ugly standard error message to confuse the user. Still not very helpful though, and it still doesn't fit in with the aesthetics of our site, very basic though they may be. For instance, here we have an example of a problem that has been caused by the user not entering the right kind of data. In this case, the email address that they entered was an invalid email. We have the whoops header, and we have a hyperlink at the bottom here. Now we could add all of this simply into here as a very long literal string, but we'd be better off including it as a function at the end of our script here, or at the beginning. We can put the function to wherever we like. But the reason why it would be much better as a function is that we're going to be repeating this data several times wherever we want to add one of these possible error messages that are going to pop up. So let's call our function fail. It's going to take one argument, string variable, message, which is going to consist of our error message. And what it's going to do is essentially copy this text. So let's copy this out of here and pop it down here. Now at the moment, this is written as HTML. And the way we output it before, earlier in the script, was to use the close PHP tag and then simply put this all in as HTML. However, we're going to be replacing this with our string variable message. So it's going to look confusing if we have to pop back into PHP and say echo message, go back in. That's a possible way of doing it, but it might be simpler and clearer if we simply echo each of these parts here to make it absolutely clear what our function is doing. So we're simply going to put our message there with a concatenation operator and then our line break, and then let's say we put this on a separate line just to keep it simple, and we're just going to put a double quotes around that and curly brackets here. The only other thing we need to do is replace these double quotes with single quotes for reasons I've explained before, which are essentially that this counts as an opening string. The next double quote that PHP comes across is going to be counted as the closing quote mark. So we need a single quote mark to differentiate. Let's save our script. We have to also add the function to the die command up here. Now, there's our fail function, and it sits here as the argument to the die command. Let's save our script, and we're going to try this on the browser. We're going to resubmit our data with the deliberate error still in the script, and we're going to see what happens. As we can see, this is a much better system because it remains consistent with what will happen if, for instance, we enter an invalid email address. If we just put in something that's obviously not an email address, we're going to get something very similar as our error message. So, although to us there is an obvious differentiation between an error that's generated by PHP and an error that's generated by our script itself, our users don't need to know about that distinction, and it will in fact confuse them more if they're coming across sudden ugly errors like the ones we found before. So we can see that this is a much better way of dealing with the errors that may pop up within our PHP scripts. We can also replace these errors here, or these messages here, with the fail function. And since every time we use our fail, we're also going to want to exit the script, we could also enter that exit as part of our fail function, which is not going to be used when we use it as part of our die command, but it is going to be used when, for instance, we're checking to make sure all the fields are filled in, or checking to see that the email is valid. So again, we can use the please enter a valid address, and we're going to lose this little bit of HTML, and as we can see, much clearer, more concise script, no repetition, by using a function. And we can use that function both for validation like this and for error checking like this down here. We're going to look at another more comprehensive way of dealing with errors in our next module.